I would like to go ahead and start the next session, the first session for today. And this is going to be on measuring soil health, measuring progress at improving soil health. And Dr. Mara Cloutier, one of our many esteemed research soil scientists, and also she's a program director for the Soil Health Institute. She's going to moderate that session. We'll have, I believe, four speakers. I'll turn it over to you, Mara.
Excellent. Thanks so much, Wayne. And thank you to everyone who is here for the session today. It's an honor to be a part of the program and to moderate the session on measuring progress at improving soil health. So this is going to be all about what does progress look like and how are we measuring that? It's something that we spend a lot of time thinking about at the Soil Health Institute, as I'm sure many of you do as well. So, as Wayne mentioned, we're going to be hearing from four folks on the panel today, the people surrounding me in the Zoom call, who are helping to make progress in this space. Each person is going to give a presentation, and then at the end of the fourth presentation, we will open it up to questions from the audience, and I'm going to be pulling questions from the Q&A box. So, if you have questions, please make sure that those go into the Q&A box and upvote any questions that you would like to see answered. So with that, it's my pleasure to introduce the panelists for this session. First, we have Dr. Jason Ackerson, a program director and a research soil scientist for the Soil Health Institute. Following Dr. Ackerson, we're going to be hearing from Dr. Cristine Morgan, the Chief Scientific Officer for the Soil Health Institute. And then we're going to be hearing from Mr. Cam Ogilvie, a soil health educator at the Soil Health Institute. And to round out our panel, we're going to be hearing from Dr. Kristen Veum, a research soil scientist with the USDA Agricultural Research Service. So without further ado, Dr. Ackerson, would you please kick us off?
Yeah, thanks, Mara. Let me pull up my slides here. Boop, boop, boop. Oh no, slideshow mode. All right. So, like Mara mentioned, the session today is all about measuring soil health. So I'm going to kick us off with this sort of discussion on some of the work we've done at SHI, focusing on measuring soil carbon and scalable ways of quantifying soil carbon stocks. Um, But like I mentioned, the talk will focus a lot about carbon, but we are the Soil Health Institute. We're not the Soil Carbon Institute. And so it's important, I think, to frame the discussion around like the importance of carbon, not just from a climate mitigation perspective. We hear a lot about carbon sequestration as a tool to combat climate change, but it also is a really strong indicator of functional changes in soils. So the slide I'm showing here is some work from Diana Bagnall, another scientist at SHI, and it really demonstrates, the importance of carbon concentrations in driving soil functional characteristics. So what we're looking at here is a graph of available water holding capacity versus texture and carbon concentration. And as the carbon goes up, the availability of the soil to hold and store water also goes up. So we're seeing improvements in soil function. So, when we talk about carbon, just remember, it's just one piece of the puzzle, and it's one of the strong indicators of soil function. And we care about it for multiple reasons. The other thing I want to sort of get everyone's heads around is when we talk about scale. Really, this was something that took me a long time to come to terms with, moving from academia to working in the nonprofit space, is the scale at which we're trying to quantify things is much bigger. We're not talking about plots or fields that scientists usually are accustomed to dealing with. We're talking about measuring, soil health for, whole states, for whole regions, maybe for whole continents. So the map you're seeing here is some work from a collaborative partnership between the Soil Health Institute and Cloutier, and the size of these dots represent the number of soil samples we needed to collect in these various areas to support their carbon and soil health programs, with the largest circles representing 1,000 samples over a 3-year period. So you see that just to kind of understand or try to quantify a small sliver of soil carbon concentrations in the Midwest, we're collecting tens of thousands of samples. And so when we think about tools to measure soil health, they need to really address this question of the number of samples we might need at these large spatial extents is really, really big, and that means it's also really expensive. And so we need to focus on tools that can get us, measurements that are usable and also cost effective. Because when you think about the cost of tens of thousands of soil samples, even at $50 to $100 a sample, that could be cost prohibitive for most organizations trying to do large scale quantification. So one of the things we've done a really good job at the Soil Health Institute is focusing on scalable measurements. These are tools that I think are, when we think about the characteristics of a scalable measurement, it's something that's accurate, it's fast, and it's cheap. And you heard from Liz yesterday talking about the Slake smartphone app. I think that's a really good example of a scalable way of measuring soil health, right? It's a tool that gets the soil aggregate stability really fast and really cheap. I'm going to be talking about another tool SHI helped develop, which is shown here in the bottom left-hand graphic, which is a handheld visible near-infrared soil sensor. Um, the sort of like cheeky title for my talk is In Situ Visible Near-Infrared Spectroscopy, the not so easy way to measure soil organic carbon for cheap. And I mentioned that because like this work really required a big team of scientists, not just at the Soil Health Institute, but across a bunch of organizations. So the core of the work I'll be discussing was funded by DOE's ARPA-E Smart Farm program, which is a grant that SHI helped administer with partnerships from University of Nebraska, University of Sydney, and then our tech to market partners at Yardstick. So we had a pretty large interdisciplinary team that focused on, this question of how do we build scalable soil organic carbon stock measurements. And the nexus of that idea was what we called the Deep Sea Project. And the goal of this project was to develop a sort of technological ecosystem that included advanced soil sensors, soil modeling techniques, soil sampling techniques in a sort of pipeline that provided better measurements of soil organic carbon concentrations at a lower cost to provide scalable inventory for soil organic carbon stocks. So again, thinking about tools that we could use not just for small plots and fields, but hundreds of fields and thousands of acres. So figuring out tools that really provided better soil organic carbon measurements at a cheaper price point. Um, and that's sort of where we landed with our handheld soil organic carbon probe. This is developed with our tech to market partners Yardstick, but it represents, 5 or 6 years of intense research in the DOE deep sea team and probably several decades of work that we've done in the in situ spectroscopy space. But the nuts and bolts of this are a handheld probe that can measure soil organic carbon stocks. So in the upper right-hand panel is an example of an operator using the probe. It's essentially a big fancy instrument that hooks up to a handheld cordless drill. And you pull the trigger and the drill drills itself into the soil. And as it's drilling itself into the ground, it's also collecting, a video, is one way to think about it, of what the soil looks like in sort of like multi-dimensional space. And we can take that video signal and convert it into a measurement of soil organic carbon stocks. So maybe a bit more of a like cartoon of how this works. The image on the left is showing, the probe tip as it's inserted into the soil. And right where that arrow is pointing is a small little circle that is a window where a light is reflected out of the probe. It reflects off of the soil surface, and that backscatter reflection is captured by the spectrometer on board the probe, and it gives us a spectral signature that we often call like a soil fingerprint. And you can think of these like fingerprints because as the soils change, and each soil is a bit unique and different, just like fingerprints, we see a different signature coming out of the soil. And by pairing those fingerprints with an actual soil sample, we can develop models that convert the fingerprints or the spectral signatures into a prediction of soil organic carbon concentrations or stocks. And so this is like 10 years of R&D to get us to the point where we can scan a soil and predict the soil organic carbon stocks in the field. And so what I'm going to show you are some results from using that probe in commercial projects. So what you're looking at here is one site in Kansas where our commercial partners, Yardstick, utilize the probe to measure or quantify soil organic carbon stocks. So each of those circles indicates a field, roughly 80 to 100 acres. So we're dealing with, roughly 500 acres here in this project domain. And at each of those fields, they collected a bunch of soil samples and probe measurements. And we compared how well the probe predicted the carbon stocks to how well the actual physical soil samples represented the carbon stocks. So the graph you're seeing is a representation of the probe predicted carbon stocks at each place where we measured carbon versus the laboratory measured carbon stocks. So that's the traditional way of measuring soil carbon stocks. So taking a sample, running it through a combustion analyzer, and then predicting the carbon stocks. So if the probe were working 100% perfectly, it was the most beautiful, perfect instrument, you would see all of those blue dots would line up along the orange one-to-one line. And what you're seeing is there's a bit of scatter in the probe. It's actually, sometimes over-predicting, sometimes under-predicting the amount of carbon stored in the field. And so what we're seeing here is a demonstration that although the probe is predicting carbon stocks, there is some imprecision in those predictions. And so for the scientists on the call, we're seeing an R squared of around 0.56, which in the in situ spectroscopy space is good. It's not going to blow anybody's, socks off, but it's a decent serviceable prediction. But the question really then becomes like, how good is this if we want to quantify carbon for that whole project? And that's a bit more nuanced of a question. So the last slide, we looked at just point measurements of carbon stocks, but that's really not what we want to know when we're thinking about a project or a field. What we really want to know is how much carbon is in this whole area. And so to do that, we have to do a little bit more statistics, a little bit more sampling design. And this is where, our team, the Smart Farm team, really did a good job of thinking about the statistics underlying how do we go from points to field predictions. So you're seeing here sort of a graphic representation of how we would stratify a field. So the map here shows a bunch of different soil types outlined in various colors. And in each one of those, we collect a different amount of probe samples or physical soil samples. And then that allows us to estimate, how much in that blue soil, how much carbon is there? What's the carbon stock on average for that blue soil? What's the carbon stock for the green soil, the purple soil? All of the soils in the project, we can estimate the carbon stocks for. And then we can take those and do a weighted average based on the area that soil covers in a project domain, and the carbon concentrations or stocks of that particular soil type, and then get an average representation of the total amount of carbon in the field. So we're thinking about not just what's the carbon at a point, but how much carbon is in a collection of fields or the aerial amount of carbon. And when we look at the probe performance at these sort of project or field level inventories, we see that despite the fact that the probe had a little bit of imprecision, it actually does a really good job of representing the total amount of carbon in an area. So when you consider the spatial uncertainty and the variability within each of the soil strata, when we compare carbon quantifications with the probe to carbon quantifications made with traditional measurements, they actually align quite nicely. So the graph here is a density plot, which shows our certainty around how much carbon is in that collection of fields in Kansas. The blue represents conventional samples. So this is the traditional soil sample. Take a soil sample, bring it to the field, analyze it, and then do all of that math I showed on the previous slide. The blue is doing all of that, but instead of taking the sample to the lab, we're just taking the probe, making a measurement in the field, and then using those data to predict the amount of carbon in the field. So we see we have very similar amounts of carbon with really comparable margins of error or uncertainties around those carbon stocks. So, we have a tool. I want to just kind of wrap up here with saying, in situ spectroscopy is a really useful tool to provide scalable quantifications of soil organic carbon stocks. It can be much cheaper on a per sample basis because all you're doing is drilling a probe into the ground. You're not taking a soil sample and shipping it and analyzing it. But there are trade-offs in precision. So when we try to do this in situ work, we don't have as precise of a point measurement. But ultimately, when we're answering the question, how much carbon is in an area, in a geography, in a collection of fields, or in a state even, that point level precision is not as critical. And when we use the probe to do those kinds of inventories, we see really comparable measurements of total carbon stocks for project areas. Mara, I think that's me, and I'm up at time. So,
Fantastic. Thanks, Jason, for keeping
yeah.
us on track too. So Dr. Cristine Morgan's going to share next, and please remember to throw your questions in the Q&A because I'll be pulling from those at the end of the session. While Christine's getting ready, I just want to say, Jason, I've seen you present on this work so many times, and every time I feel like I take away a new nugget of information. I always appreciate hearing about all your work with the Viz and IR carbon
Thanks,
stock.
Mara. That probably means I'm missing some things every time I talk about it. So,
All right, Dr. Morgan, you ready?
Yes, thanks, Mara. Well, hello, everybody. Again, it also is an honor and a pleasure to have the opportunity to celebrate with everyone on this meeting our 10th anniversary at SHI. So I'm pleased to be here, and I'm pleased to show you a little bit about some of the accomplishments and, most importantly, what we've learned and how we're communicating that information that we have learned about how the adoption of soil health management practices are moving the bar, not only in the health and functioning of the soil, but also in outcomes associated with that, the ones that ultimately the reason why we want to improve our soil health. So just big picture again, it's all about scale. I think Jason set this up. I think Kristen and Cam are going to follow me with the concept of scale, because we all realize that there's a heck of a big job in front of all of us in thinking about how do we quantify soil health nationally, globally, and how do we do that scientifically credibly. And these are the pieces as far as we've been thinking about the Soil Health Institute. Like, how do we assess soil health at scale? Well, first of all, we need to define what we're going to measure. And at SHI, we have defined our soil health and management practices that we want to quantify. And interestingly, for us at SHI and many others, we want to make sure that these measurements are scientifically valid and meaningful. So often when we give talks, we show the peer-reviewed manuscript that we have put this information into if one wants more detail. But most importantly, we've learned the measurements have to be accessible through commercial labs for farmers and ranchers to be able to access them. Cam will talk a little bit more about that today. And they need to be practically measurable at scale, meaning that, bulk density is a really tough measurement for just anybody to go and collect. I still struggle with, 20-something years of experience collecting bulk density. We also need to think a lot about where to measure. Jason teed that up a little bit again, but I just want to recognize that all soils can be healthy. So when we go into an area, we need to make sure that when we measure soils, and even a healthy sandy soil and a healthy clay soil, they're going to have different values for their soil indicators. And we need to keep that in mind when we're thinking about where we're going to sample, how many samples we're going to collect, because ultimately we need statistical power to scale this information. And again, the scale thing keeps coming in because we want to be able to do this continentally, but it doesn't matter if we can do it for the globe or for a continent if it's not locally relevant to an individual farm field. And that's what we all really focus on and struggle with in the soil health community. But lastly, and most importantly, our values at SHI are that when we collect this work and we do the science and it's credible, we've got to communicate it well, meaning that outside of science, outside of our bubble of soil health, the information needs to be understandable, actionable, and credible. And that is something, as in my years at SHI, that I've learned a lot about, and hopefully will continue to grow and learn more about how we can make our information understandable. So just to back up a little bit on the measurements, I think probably most people on this call are aware of our North American project to evaluate soil health measurements. We had this goal to identify the most effective measurements for soil health. We looked at 124 sites, all with scientific partners across the US, Mexico, and Canada. We uniformly sampled those sites in 2019. They had treatments and controls, so they were paired management changes, and we collected a lot of measurements. What did we learn from that? We have published on our essential soil health indicators. We published a a lot of papers at SHI, and also our partners have published papers. We're working on publishing, but have also identified and talked about management indices, how, like, for every soil measurement we make, we also want to make sure that we get a good measurement of the management. And those management indices are based on NRCS soil health principles, so that they are principle based and not just, binary, did you do this, did you do that? And then lastly, we really want to tie these indicators to outcome assessment. What is the impact on water cycling? What's the impact on carbon cycling? And what's the impact on yield, right? And so we thought a lot about the yield thing. A lot of folks have asked us, what did you learn from NAPSHM around soil health and yield? And interesting, at first we learned kind of what everybody else had learned, is that if you look at management change and yield at a large scale, you don't get a lot of information. So when we try to look like, okay, has management changed? These long-term plots, we had management change for at least 15 years, and we also had 5 years of yield data. And the way we looked at this, we found kind of consistently with what the literature said, is like yield sometimes responds to management change, sometimes doesn't respond to management change. It's inconsistent. And that's what our data showed too. So this is a meta-analysis plot. On the y-axis is relative change in yield. And the 0 is all the controls for these experiments that we had for NAPSHM, right? So the 0 means that, it's just a normalized reference, like, okay, there's no change at all. It's same as the control. And what we found is that when we reduced tillage in the NAPSHM sites, we got the dot is the mean change. So we got a little bit of the difference between the control and the treatment, the treatment being reduced tillage, but it's not statistically significant, because this confidence interval goes across the 0. Same with residue retention. Wow, we got over a 10% change in yield, but again, not statistically significant. And then cover crop, same thing, a very small change in yield. So what we're seeing is like, yeah, management seems to be improving yield on whole, but it's not past, we don't have a lot of confidence that this is happening. And so it gets back to that inconsistent. We can't see what's happening. Interestingly, though, with NAPSHM, we also measured that change in soil health. And so now we have the soil health management, the change in that health from the control to the treatment, and the change in yield from the control to the treatment. And when we do that, you're now looking at the same plot, and here's the 0. But when we just categorize not the management, but did the management change the soil health? And so the green dot are the sites where 2 or more soil health indicators increased, or 3 or more soil health indicators decreased. And then the gold dot is where the soil health indicators decreased. And now what we see are, if the soil health is improved, we have a significant improvement in yield, and our confidence is strong, and it's significantly greater than 0. So this was, I frankly will say, from a scientific point of view, a relief that we could tease out the noise in this kind of data. But it also just reiterates to us at the Institute is we're working hard to measure change in soil health, and our efforts are important. If you treasure it, you measure it, and we treasure soil health change, because when we adopt a management practice, we don't always improve the soil health. And for many reasons, like environmental reasons, ability to get the cover crop going, compaction through no tillage. There are things that happen when we adopt management practices that can decrease soil health. So, moving on, we have these soil health indicators, and just to review with everyone what they are is organic carbon concentration, aggregate stability, carbon mineralization potential, which I think about as the microbial activity, and available water holding capacity. And generally, when we think about these 4 measurements, every time I talk to either a microbiologist or a physicist or a chemist, we all get back to this aggregate stability measurement because it really integrates all the components of increasing organic matter, increasing microbial activity, and improving water functioning for the soil. So the aggregate stability is something I really like. Okay, so then how do we think about this? We have these 4 measurements: soil organic carbon, mineralization potential, aggregate stability, available water holding capacity. And then we have soil. And what I said earlier is all soils can be healthy. And here's an example. This is one soil. Picture was taken on the same day. The picture on the left is a conventionally tilled wheat system in the Pacific Northwest. If you hang around for Liz's demonstration yesterday, you've seen this picture. And on the right is a soil that's in a perennial system. And obviously, on the left-hand side, after this rain, the soil in the conventional system is not functioning very well for water cycling. And the soil on the right is, because it has better aggregate stability. And we can see that. If we look at this aggregate stability line, on the right-hand side is the reference aggregate stability number in green. Remember, we did replicates at NAPSHM, so we have 0.49 for aggregate stability of the reference, or the soil in the perennial system. And for the baseline, we have 0.21. And then I don't show a picture of it, but this same soil was also had replicates in soil health management. So it was 18 years of no-till and cover cropping. And we can see that the soil health system moved the needle. We don't know when, but we know sometimes between year 0 and year 18 that we had an improvement in soil organic carbon, mineralization potential, aggregate stability, and water holding capacity. And you can see it in the picture, right? But we're scientists and we need numbers. The other interesting thing to note is that the soil health didn't always reach the reference state. And we recognize that can happen because the reference, we're trying to measure how good can that soil get. This soil in this climate, how good can the soil health indicators look? We're really trying to bracket what we can expect. And that gives us some relative interpretation capability. So here we go. Let's try this at scale. So we think about soils. We map them across the U.S., soils that we think are going to be similar, and we go out to a region, and for those similar soils, we go and measure them under different management systems. We lazily call the left-hand side our baseline. What is the preponderant soil health management for a region? In the middle, this is a cotton system in no-till with cover crops. And on the right-hand side, we have a reference date, which is some sort of perennial. In this case, it's a fence line. We're not looking for, virgin prairie when we go out and try to sample these references. We're trying to find what we can find. And where have we done this? Wayne showed this yesterday. We have these highlighted areas, and the colors show you the major land resource areas in which we've gone in and benchmarked. In all cases, we have not benchmarked the whole major land resource area, but we have benchmarked a reasonable, a good representation of it. That representation represents about over 19 million acres to date, with half of that being in the cotton belt, so cotton growing soils that also grow other things like peanuts, wheat, corn, sorghum, and California tomatoes, and other high value vegetable crops. And we've gone into dairy areas. You'll notice the brown in Wisconsin and New York. We've also done it in Texas and New Mexico, but we don't represent that in acres, so it's not in this 9 million. Mara insists that we represent that area in dairy cows. So that area in brown represents over 1 million dairy cows fed in forages. And then we've also done the Greater Golden Horseshoe in Ontario, Canada, and the Des Moines Lobe of Iowa. And so the question is, what does this look like? So I'm going to start with the cotton area. And so on the left-hand side, you will not be tested. We're looking for general patterns. On the left-hand side are all the states that we have benchmarked to date, that we have the data back for cotton growing major land resource areas. So we have the state and the name of the major land resource area. And then each of these columns represents a soil health indicator. And if the yes is in the box, that means for that area, when farmers adopted no-till and cover cropping, or whatever the soil health management was in that area, if the soil organic carbon improved statistically significantly, so at a confidence of 5% or 95% confidence, then I put a yes in the box. And so what do we see? We see that aggregate stability is our ace in the hole in measuring and monitoring soil health. But then we also see that soil organic carbon is not always improved by the soil health management systems that we were able to observe. That does not mean that you cannot improve the organic matter statistically. It just means that for the practices that we were able to observe, we could not see that improvement in every single location. But we do see a lot of times that we don't see organic carbon improving, we see that the microbial activity improving. For the row crops compared to row crops in Iowa, Ontario, and Canada. So in Iowa, again, it was the Des Moines lobe. We're talking corn and soy. In Canada, small grains and corn and soy. And what we can see again is aggregate stability was also, again, statistically significant. We did see increases in carbon, but they weren't statistically significant. And then in dairy, which is a very different system than any of the other systems, you have to think that these are systems with a lot of forage removal and a lot of manure application. And so what I did here is the traditional yes here is how I've explained it. You have baseline. But then in the gold yeses are talking about, are comparing our baseline systems to rotationally grazed forages. So we were able to improve a lot of the soil health indicators if we went from a row crop system in dairy forage production and dairy grain production into a rotationally grazed dairy production system. And so how are we reporting this? For each region, we're coming up with these benchmarking reports. The reports show the systems that we measured. They show what we found, what were the actual measurements for a given soil, and then we try to give a conclusion on what actually was working in the area and by how much did it improve the soil health. The cool thing is about each of these regions is that we printed these tables up, even though our models are continuous. We said, okay, what are the two predominantly productive agricultural soils in the area? And we were then able to report the mean baseline and the effect of the soil health management practices and the reference values for each of our indicators for instance, in the southern high plains of Texas, a sandy loam soil, and sandy loams and clay loam soils in the southern high plains cover a lot of the soils. So in summary, we know that soil health improvement is linked to outcomes, so let's treasure it and measure it. The Soil Health Institute benchmarking approach is scalable and locally relevant. We're recognizing soil's multifunctionality. We've always known this. It's one of the things that makes it complicated to measure and report on soil health, but we're seeing it in the data as well. And we're also thinking the regional reports can be multifunctional too. They can be important to producers and also to those that are interested in purchasing or understanding from their supply shed what is the impact of adopting soil health management systems. So next at SHI, we want to continue to benchmark. We want to improve access to benchmarking and soil health reporting, which is what Cam is going to talk about. And ultimately, we want to translate these soil health indicators into soil functioning. With that, I just want to acknowledge our funders and the teams. This benchmarking project, as probably Kristen can also acknowledge in her work and looking at soil health, it takes an army of folks to get access to fields, people to sample, data analysis, and then the resources to support that. With that, I want to thank you for your attention, and I'll send it back to Mara. Mara, you're on mute.
You hear me? You can now? Okay, good. Oh, phew. I know I got kicked off once. So what I was saying is, Christine, I always appreciate how well you can like pull all the pieces together of what we do at the Institute and make a really coherent, perspective shifting presentation. So thank you for that. I'm going to pass it over to Mr. Cam Ogilvie, who's going to be presenting on a new project that we're working on and hopefully getting to kickstart in 2026. Cam, take it away.
I was getting teased earlier, if you didn't hear it, about looking like the Canadian Steve Jobs. And I realized that when I put on my clothes this morning, I was trying to channel my product release event kind of energy. And so that's what you're getting today. I'm really, really excited to tell you about something new that's coming in 2026. I'm going to get into a little bit more detail, but I'm going to repeat some things that Christine already said that we've been saying the past couple of days. Unfortunately, you're not going to be able to leave this annual meeting without hearing about what our essential indicators are. This great work that we did across North America to try to understand which are the measurements that are sensitive to changes in management, which ones work across the various regions and soils, which ones are accessible and affordable. And so we kind of boiled that down into 4 essential indicators. You can read more about these if you go to that QR code or if you read Diana's paper. And then you should also know now that we've been using these indicators to do benchmarking work across North America, and that we've benchmarked over 19 million acres to date in corn, cotton, veg, dairy forage systems. And that one of the great outcomes of this benchmarking work is various reports. And here I'm going to call on the report from my colleague Jenny Bauer, who is doing some great work with the Greenbelt Foundation in Ontario. And these benchmarks provide context for growers so that they can interpret their soil health test results. So when I get a soil organic carbon concentration of 2.35, what does that mean? Well, in the Greenbelt of Ontario, because we sampled soils that were under high amounts of tillage and soils that were under lower amounts of tillage with cover crops, and because we sampled these perennial references, these fence rows and pastures, we have an idea of where that 2.35% sits for that soil type. And so, of course, context is really, really key for being able to interpret soil health indicators. But I'm an educator. I'm a soil health educator. I'm not going out and doing the research here. My job is to go around and engage with farmers, crop advisors, companies. And when I'm doing that, when I'm talking about the work that SHI does, there is a typical conversation that takes place. And it starts something like, oh, there are so many soil health tests out there. Which ones should I use? And you should be able to answer this right now. You should know what I'm going to say. I'm going to talk about our essential indicators. That's what we recommend. And then the follow-up to that is, oh, these sound good. Well, how do I know if my results are good or not? And you could probably finish my sentence. I'm going to talk about benchmarks. We use these to help interpret and provide context for our results. And then this is the fated question. I like this. What labs can I send my soil to get these tests run? And that is what always kills the conversation. It dies right there because we knew for NAPSHM and for all of our benchmarking work that we couldn't just send our samples to different labs willy-nilly because different labs have their own internal standard operating procedures, and that would introduce variability into the data, and then we wouldn't have confidence in the data to be able to build benchmarks that are interoperable. So we had to only work with one lab, and that just left us in a place where we didn't feel it was appropriate to recommend labs to those that we interacted with. But I'm pleased to tell you today that this is all about to change. And so next year in 2026, the Soil Health Institute will be launching a new soil health assessment program in partnership with soil testing laboratories. And we will be announcing several partner labs in North America next year that you can go and get your soil health tested with our essential indicators. If you've been around SHI for any length of time, you've also heard us talk about scale. And this program, I don't think it's an understatement. It is going to allow us to scale up soil health like never before. Now, there's 3 reasons for this. Number 1, the data is interoperable. You will be able to send your soil sample to any of our partner labs in the world and know that the results you'll get back would be the same. Not only does this provide farmers, ranchers, crop advisors more flexibility in choosing where they want to send their samples, it is a major unlock for supply shed sustainability reporting that crosses regions and national boundaries. Number 2, the results are interpretable. Wherever we have enough data, if you send a soil sample to one of our partner labs from that area, you get access to our benchmarks so that you can make sense of your results. And the more people who use this program, the more data there is for creating the benchmarks, and the better the benchmarks get. And it's a virtuous cycle like this. Number 3, the tests are affordable. We are, as we've said, we're measuring just the essentials. So users don't need to pay extra for redundant or difficult to interpret and expensive measurements. But I don't want you to hear me wrong on this. We are scientists at the end of the day. We love exploring new and exciting measurements. What we're talking about here is that for this program, we want to focus on an essential suite of measurements, not an exhaustive one. And we're going to do the exhaustive measurements in other projects, but for this is the key to keeping it affordable and scalable. So you may be wondering at this point, okay, what's this partner lab and how do you become one? Okay, well, a partner lab is a commercial or non-commercial soil testing laboratory that has been qualified to measure SHI's essential indicators. They participate in ongoing proficiency testing and quality assurance and quality control. And because of that, they can be trusted to provide interoperable soil health data that's fit for use in benchmarking and sustainability reporting. Now, how do you become one? What's this process? Well, it's quite simple. 2 steps. Number 1 is an assessment and training step. We recognize that labs are at different places when it comes to their familiarity and comfort with soil health testing. So for labs that have no prior experience, we can bring you up to speed on our measurements, the equipment that's needed to run them, the standard operating procedures that we require. We can train you on all of this. What is required for all labs that want to become part of this program is that we come and do an on-site assessment, watch that lab run these tests, go through the SOPs, and then we're going to follow up with some initial proficiency testing to make sure that the lab is generating the results from these tests that we expect. Once that step is completed, we move on to partnership, and that really starts with signing a laboratory partnership agreement with SHI. And one of the key requirements of that partnership agreement is ongoing proficiency testing and data QC. With that agreement signed and in place, the lab gets our stamp of approval, and they can begin advertising their services as a partner lab of the Institute, measuring our essential indicators. Okay, but there's lots of you on the call who are not a lab, and you may be wondering, how do you start working with a partner lab? Well, the first place to go for this will be our portal. We are building a full service portal to manage this whole partner lab program. This is where you will be able to find a partner lab near you. You'll be able to identify the fields that you manage, enter some very basic management data for benchmarking categorization, create sample labels, receive results back from the lab, and access the benchmarks for your region and your soil type. When this goes live, farmers and advisors will be able to create an account for free. There will, of course, be a cost associated with the laboratory analysis, but creating an account, getting started in our portal, there's no cost to that. And you're going to hear more about this early in 2026. Okay, so I said this whole partner lab program just isn't quite ready yet. We're still keeping things a little bit under locks at the moment. So I want to end with, what can you do in the meantime? And the first thing I want to say for everybody on this call is connect with us. Follow us on social media, LinkedIn and Facebook. I'm even told lately that we might even be on the gram, for all of you Gen Z or Gen Z if you're Canadian out there. So follow us on social media. Go to soilhealthinstitute.org and subscribe to our newsletters so that when this all goes live, you're not going to miss out on it. Beyond that, I think there's a unique call to action for a variety of different groups. If you are a lab listening in, and I know that there were over 30 labs who registered for this annual meeting, get trained and assessed. Talk with us about this. As I mentioned, we've got several labs that are in the pipeline already. But that is going to fill up quite quickly next year, and we only have so much capacity to onboard new labs in a year. So if you want to see yourself as part of this program next year, let's get involved, reach out, talk to us. And I also want to say that while the focus for probably the next year or so is really going to be getting this launched in North America, we do not want this to stop there. We want to see partner labs around the world. And so if you're a lab somewhere else in the world, reach out to us. We want to have the conversation. We want to get this moving. If you are a farmer or a rancher, talk to your lab and encourage them to partner with us. If you care about science-based, interpretable soil health assessments, your lab needs to know that. Your lab needs to know that that service is in demand and that there's a business opportunity there, either for them or for somebody else to pick up. So talk to them. If you are an advisor, use our partner labs to start offering soil health assessments as part of your agronomy service. Once this portal launches, as I mentioned, you'll be able to create an advisor account, and that will allow you to manage the samples and data on behalf of your clients and generate reports for them. All that you need to know is how to sample for our essential indicators and how to use our benchmarks to interpret them. And if you need other things to help make this easier for you, talk to us. We want to make this as easy and accessible as possible. If you are a company that's listening in, because the data from our partner labs is going to be interoperable, it is a perfect fit for corporate sustainability reporting, especially if you source commodities from across regions and national boundaries. As Liz mentioned yesterday, we're also working to have our SLAKES measurement ISO certified, and that would put all of our essential indicators into a position where they're all internationally accepted as soil health measurements, which I know for my Canadian counterparts on the call has been a really important topic of conversation with the passage of Bill C-59. Better yet, if you are a company, talk with us about getting an aggregator dashboard in our portal. We have the ability to create customized dashboards to further help you create soil health reports with data from all of your suppliers. So let us make soil health reporting super, super simple for you. Finally, I know that there's a large group of researchers who are out there, and you're maybe wondering, how do you get involved? Well, you could become a partner lab also. Even if you are not offering soil health testing commercially, you could still be trained and assessed to become a non-commercial partner lab, and that would enable you to contribute data towards these soil health benchmarks. In all of these kinds of cases, you retain ownership of your data and you determine how it is used, but we would love to partner with you in making that data accessible and actionable for the farming community. So please reach out to us to learn more. I've put my email there at the top. You can contact me if you like. I'm going to wrap it up there, and I want to make a few important acknowledgments. There's a number of folks on the SHI team who have made an outsized contribution to this initiative, and so I want to thank Liz Reiki, Aaron Hurahan, Cade Flynn, Jenny Bauer, Mara Cloutier, Cristine Morgan. Thank you so much. I also want to thank some important funders who've been a big part of getting this program off the ground: the Ida and Robert Gordon Family Foundation, the Walmart Foundation, and Cotton Inc. And that's where I'm going to end it for now. Thanks, everyone, for your attention.
Fantastic. Thank you, Cam. Yeah, we've got a lot of excitement over in the Q&A from your presentation. So that was a great way to kind of wrap up the Soil Health Institute's progress on measuring progress and improving soil health. Somebody else who also is making great strides in this space is Dr. Kristen Veum. So I would invite her now to share with us her work.
Okay, well, thank you. And Cam, that is really exciting. That was the first I'd heard about that program, and I'm excited to hear about these efforts to help everyone harmonize data. So I want to start by thanking everyone at the Soil Health Institute for the opportunity to share an update on our project called Probing Our Country's Soil Health, funded by the NRCS Soil Health Division. So the main objective of this project is to build out and enhance the data set behind SHAPE, which is our new soil health interpretation tool. So I'm going to start by providing just a brief description of SHAPE and how it works. So it was developed between 2017, 2024 by a team of ARS, NRCS, and university scientists. And most of this work, at least the modeling work, was done during COVID when we were all stuck at home. So this was a great project for us to focus on during that time. But overall, the SHAPE tool works by forming soil peer groups that are based on soil texture, soil taxonomy, and local climate conditions. And then the most recent version of SHAPE also incorporates spatial proximity. But these peer groups define, what's possible for a soil at a specific site. So in essence, a soil can move up or down that curve within its peer group as a result of management changes. So to score a new soil sample, as in this example, you enter your site information and your laboratory results. And so for this example, the lab measurement for soil carbon was 2%. And then the tool will return a score. So in this case, it's scored here where the black dot is at the 77th percentile. So that tells you where that sample is relative to its peer group. And then it also provides a benchmark, which the default setting is at the 95th percentile, but you can choose any benchmark percentile that you want to target. And so in this case, for this example, the 95th percentile for that peer group is 3.6% soil carbon. And then you calculate your opportunity gap, which is the difference between the two. And for this case, that's 1.6% carbon. So I know I went through that pretty quickly. So if you're interested in all of the gory statistical details, I invite you to read our most recent paper that we published in the Soil Science Society of America journal. And I'd also like to point out that the tool is publicly available as a Shiny app. And we share the executable files with anyone who wants them. So if you know how to create your own platform, you can take those executables and plug them in wherever you want. But our Shiny app, I'm the first to admit it's still fairly clunky to operate. And we were hoping to have it operationalized on some of our conservation platforms last year, but we're still working on that. So that's where we have room for improvement, I will say. But when we developed the tool, we compiled data from NRCS, which is the blue dots on this map, and Cornell, which are the red dots on this map. And we had access to data for 6 soil health indicators. So we had soil carbon, we had active carbon or POC, ACE protein, soil respiration, which was the 4-day base trap method. And then we had 2 methods of aggregate stability. We had the Cornell sprinkle method and the KSSL method. But as you can see, there are several regions on this map with very low to no coverage at all. And this data set also lacked management information. And so the current tool is not able to incorporate management-specific results or interpretation in this current tool. So these limitations really became the motivation behind this new large-scale effort that was funded by NRCS Soil Health Division to create a nationwide soil health data set by collecting soil and detailed management information from over 13,000 locations across the US. But we really wanted the focus to be on real production systems. So it's all on-farm samples with real-world management conditions. We kicked this project off just a little over a year ago. through this amazing public-private partnership with AGES, that's Agronomic, Geologic, and Environmental Services, through the Center for Regenerative Ag. And they are handling all of the boots on the ground portions of the project. And then through their own amazing network, they have partnered with a wide variety of other public and private institutions all across the country to reach farmers and ranchers in each state. So to date, we already have over 600 participating farmers and ranchers, representing over 1,400 different fields with management survey information, and over 1,500 soil samples have already been collected. So this table shows the completed field surveys to date by state and across 7 broad land use categories. So the broad land use categories that we selected are, we have cropland, CRP, hay, annual horticulture, perennial horticulture, pasture, and rangeland. And then I allocated samples based on acreage at the state level relative to total agricultural acreage in the United States. And each land use type has its own detailed management survey that goes with it. So this is a fun little map that shows our progress to date. So each icon represents where a field survey has been completed. And if there's a red circle around it, that means the samples have been collected already. And the AGES sampling teams will start moving down into the southern states over the winter. And just to zoom in a little more on the map, this is a close-up of the Washington, Oregon, and Idaho region. So you can see that corn icon, so that represents a row crop system. It's not necessarily corn, could be a different row crop, but that's the icon we selected for row crop. The bales represent hay fields, and the cows are either pasture or rangeland, and so on from there. So after the samples are collected, they all are delivered here to Columbia, Missouri, to my lab, where we process them and stabilize them for subsequent analysis. And we have a lot of fun with this because the soils are all so different. We've worked on Missouri soils forever, and now we get to have soils from Utah and all across the country, and they're just beautiful. And this is also where we initiate the laboratory analysis part of the project with a focus on high throughput methods that are sensitive, reliable, and low cost. As many other presenters have already emphasized, this is very important if you're going to work with farmers and have a soil health assessment that's used and meaningful. So as part of this project, we also test method adaptations to enhance those characteristics, especially on the cost and throughput side. So we look at different methods and test different ways to improve protocols so that we can reduce the cost of farmers in the end. So as part of this project, we expect to measure up to 24 different soil characteristics, not all soil health measurements per se, that we can group into these categories, water partitioning, erosion resistance, right? So aggregate stability, soil texture, you could put in that category. Biological activity includes soil respiration and active carbon. Nutrient availability, we have ACE protein, mineralizable nitrogen, as well as a suite of standard soil fertility measurements, and then soil pH and EC, which of course are very important. And then also in the category of recycling of nutrients, we have a suite of soil enzymes that we plan to measure. But just to be clear, because I get this question a lot, no, a farmer will not have to measure all of these different things on their soil in order to get a shape score. So we're going to use this data for a lot of other things when we create this data set. But the goal for SHAPE is to be as flexible as possible and to be able to ingest data from several different labs and to include a lot of the more commonly measured soil health indicators. But a farmer can measure even just one thing or any, a minimum data set and still use the SHAPE tool. So the level 1 soil analyses are the ones that are already underway in my lab. And most of these measurements are ones that can already be scored in the current SHAPE tool. And so we prioritize these in part because we are working with real farmers and they're excited and they want their soil health report. And so this is a suite of measurements that we can currently score, create a report, and send it back to the participating farmers. But you'll notice, though, that we're also measuring multiple methods of a few different indicators. So, for example, aggregate stability, we'll be looking at that KSSL method that's already in SHAPE, plus a version of the IGLCAMP, if you're familiar with that apparatus, which is the scaled-down dunking method. And we'll also be working with the Soil Health Institute to implement SLAKES as part of this project. And soil respiration is another one where we have multiple methods. And we really want to cover the main protocols that are out there, are currently available. So it would include 1 day, also 4-day, and probably 3-day soil respiration. And as soon as possible, this expanded list of soil measurements will go out for bid from service labs. And I'm really hoping that I get the green light to do that soon. These measurements include soil characterization measurements and soil fertility measurements, along with soil health indicators. So there may be multiple labs that end up being involved in the project through contracting for these analyses. The overall timeline for our project is more protracted than we really want it to be right now. But as we forge ahead, I'm expecting our turnaround to improve substantially. But basically, the surveys are completed as soon as possible following farmer sign up, right? So they indicate interest and we don't want to lose that interest. So we get them on a Zoom and conduct the survey. And then AGES gets their sampling teams out within 3 to 6 months, depending on planning and weather and things like that. Our goal is to have those level 1 reports back to farmers in less than 9 months, but ideally even faster than that, with those expanded reports to follow. And we expect the whole project to be completed by 2028 or 2029 at the latest. So overall, the benefits of this project include representation, soil health representation across states, soils, and production systems in the SHAPE tool. And by bringing in that broad and detailed management information, we'll be able to provide management-based soil health interpretation, which will help farmers and ranchers make decisions related to their soil health outcomes, right? And then by adding these additional soil health indicators, the tool will be more flexible and user-friendly. And of course, you can't forget that awesome farmer-rancher engagement, which will increase landowner awareness of soil health, because each one gets this valuable soil health report, and they'll actually get 2, level 1, and then expanded soil health reports. And then I'm going to end with a slide of the people that are really making the magic happen. So, these are the hardworking soil sampling teams from AGES and all of the participating farmers and ranchers, because they are the difference between a good project and a great project. And I have to say thank you to all of them. And thank you for listening to me today. That concludes my presentation.
Thank you, Dr. Veum. That's a great way to round out those presentations to give thanks to all the people on the ground that are making this work and the reason why we're here. So we're going to move into the Q&A portion of this panel. There are some really great questions in the chat. Um, and I think generally, maybe before we start pulling questions in, some things that kept coming up in these presentations was the power of scalability and the importance of that, right? And making things, ma making sure that we're measuring the right things and that those measurements are things that people can afford to do and that are effective, and that we can provide data-driven, actionable insights for people who are on the ground, right? I think those were generally some things that I pulled out from those presentations. I'm sure many of you pulled out some other things as well. So I know the panelists have been busy in the Q&A too, responding to some of the questions. So some of them have already been answered. So I'll ask some of those that haven't been answered yet. So the first question that I'm gonna ask comes from Jennifer. So for soil carbon and or soil health, can these tools help measure a change over a 3 to 5 year grant period? This is something we think about a lot, and probably Dr. VM does too. So, how can one best show a change over such a short period of time when we're thinking about management changes and you only have a few years to get farmers to implement new practices in your short grant period? Maybe I'll kick that over to Dr. VM to answer first.
Okay. Yeah, that's a great question. Of course, if you're looking at a 3 to 5 year study, you want to be able to measure the impact of management. So different indicators have different levels of sensitivity. So some are like soil respiration tends to be more sensitive than soil carbon. But it also depends on what you're comparing, right? So how many different management practices are you layering together? And if you're making one change, that's going to take longer to show a difference than if you have, no-till and cover crops and, different things packaged together. So I would say if you're really looking to detect change, it's going to depend somewhat on where you are as well and the type of soil that you're working with. So the same management change is going to have a different impact on a silt loam versus a sandy soil and some of the things that Dr. Morgan was talking about. But I will hand it over maybe to Dr. Morgan and let her add her 2 cents to this.
Well, I agree 100% with what you said. And there are different, I think, just what I read in the literature that 24-hour respiration or carbon mineralization potential is a fairly responsive measurement. And again, it really depends on the soil type that you're measuring. And it also depends on the question. Generally in science, the question isn't, as general as our questions, like, is soil health improving? There's generally some other underlying hypothesis. So I would say, measure the general things that, like Dr. VM and SHI are measuring, and then just make sure you measure the thing that, most clearly answers or, addresses your hypothesis. Like, at least for SHI, the essential measurements, like, they're really general and just like kind of should be the foundational measurements is what we suggest. I've seen carbon increase in soils pretty fast. It just depends on where you are and how much water you added.
Thank you both for that. Yeah, okay, I'm going to pull another question from the chat, and I'm actually going to give this one to Cam to answer because it's something that he's been working on a little bit. So this comes from Hannah, and her question is really about like if we have considered how policy has a place in pushing scalability, but I wanted to throw it to you, Cam, so that maybe you could talk a little bit about how like how our indicators are integrated into SEMA.
Yeah, great point. Yeah, so of course policy can have huge implications on scalability. I actually do want to bring a brief mention to that Bill C-59. If you're not in Canada, you might not be aware of it, but Canada passed an anti-greenwashing bill, is how it's being dubbed. And that has had an interesting effect on the industry as far as requirements around backing up sustainability claims with internationally recognized measurements. So I think that's a really clear example. Um, to use the SEMA example, we're really grateful that NRCS has identified SHI's essential indicators as part of that SEMA 216, that conservation evaluation and monitoring activity for soil health. And so there is cost share funding that is available for measuring soil health using SHI's essential indicators. And we have the great privilege of being part of a regional conservation partnership program with McCain Foods in Wisconsin and Maine, where the fact that those indicators are a part of that SEMA is what's allowing us to be able to work with producers and get them some better insights on their soil health. So a great resource to take advantage of if you haven't already. And yeah, I think I'll leave it at that for now, unless you've got other clarifications, Mara.
No, I think that was great. Thank you, Cam.
Mhm.
Yeah. So the next question that I'm going to pull from the chat is from Ben. And this is about where we've sampled for benchmarking. I know Dr. Veum, you had kind of said, well, this is where we've done Shape 1.0, and we know where the gaps are, so we're going to go fill those gaps, right? So you've got your plan to sample a lot of those more Western ag sites, which is maybe what's also limited with what we've done too, Dr. Morgan. And I'm wondering if you could just kind of speak on our plan to fill in those gaps.
Irrigated agriculture in arid environments is complicated. I'll start with that. There's no easy answer to what we do in more arid environments, but what we have done, and I did not show, is that Mara's team has collected quite a few samples in dairy in Idaho. She's also working in potato growing regions. We have a project up in the Pacific Northwest looking at potato and even native uh, tribes places soils hopefully as well too, but just looking at in these irrigated systems how is management moving the mark. And then also we just completed our sampling in California and look forward to learning what we learned there. I mean, traditionally we stratify in humid regions, we stratify our soil sampling by soil type and management. But what we found in California is we had another strata, which is the amount of water that's added every year. So, even in California, even though it's irrigated ag, you think, okay, it's irrigated ag, but there's different water allocations. And we know that those water allocations are going to make a big difference. It's just like earlier when the other question when I answered is like, depends on how much water you add, because it's very upfront in our thinking. The other thing about arid environments is we're thinking a lot about what those references ought to be. Because really what the idea of a reference is to initially was to like understand how good the soil could look. But also, we know that when you add water, that the soil indicators could actually be better than a reference. And so we're trying to like put that all together and come up with some reasonable interpretations of how we expect soil health to look in well-managed agricultural systems in arid environments. I'll stop there. It's a lot. I see Kristen nodding too. I would love to hear. Maybe we don't have time here, but offline on her thoughts in arid environments as well.
Thanks, Christine, for bringing all that perspective. Yeah, it's definitely very challenging. Some days I wish I was on the cotton project because it's a little easier, but that's okay. Cam, I'm gonna throw another question to you. This one was from Ayush. Because there was a couple mentions about this in the Q&A about like, expanding globally, the lab partnership. And you had mentioned just like maybe given one line in your presentation, maybe you could expand on how we envision growing past just North America.
Yeah. Well, core to what we talked about this program is partnership. And so I think that's the word that it's going to keep coming back to in every case. We want to work with labs internationally. We recognize that not all labs are going to have the equipment to run some of these measurements. And so let's have that conversation. Let's see what equipment is available. Let's talk about whether or not that equipment is affordable. And if it's not, let's talk about solutions to get that in place. In some cases, we have companies who are demanding this service, and it may be companies who are driving the adoption of these measurements by labs internationally. It may be policy, as we just talked about in that previous example. But at the core of it, it's always going to be a partnership. It's going to be about relationships between SHI and those labs, and what can we do to make a solution work.
Yeah, absolutely. Thanks, Cam. All right, we have 3 minutes left in our session. And I was thinking maybe we could do round robin and everyone kind of responds to the same question. I'm trying to choose one. There's so many good questions still left in the chat, but I'm gonna choose this one. This is from Sainfort, and it's how do we integrate the many ecosystem services that soil health building practices provide, but are not reflected in farmer profitability? And in some cases, those may reduce their yield or profitability in some situations, right? We know that cover crops don't work everywhere necessarily. And I think this ties in well with some of the conversation that we heard yesterday too, where profitability is so important. So I'm going to kick this question over to Jason first to answer.
Wow, thanks, Mara. Yeah, I think that's really tricky. I think, when it comes to profitability and ecosystem services, I think, we heard yesterday from a good panel of supply chain partners and thinking about ways of integrating the value of those ecosystem services, embedding that in the supply chain. And I think really that's probably the trick if we want to try to find a way of rewarding growers for those ecosystem services that might be at odds with immediate or short-term profitability, is figuring out how to embed that value in the supply chain. But like cornerstone to that is like we need assessments that can actually make claims around ecosystem services within the supply chain. And right now we don't really have those tools because, like Cam showed, we're really lacking a system of standardized measurement practices and the labs to execute those practices that could then roll up into a supply chain quantification. So I think it's a really tricky question. And I'm very excited to hear what Cam and Cristine and Kristen have to say about it.
Well, with not too much time left, I want to let Dr. Veum respond if you have anything. We'd love to hear from you.
Well, sure. So I have to say, this is like the holy grail, right? Is being able to take all of the soil health measurements to that final step, right? Those ultimate outcomes that we care about, and water quality and things like that. And even when we think about profitability, people focus in on yield typically, but that is not necessarily the same thing as profitability, because if you factor in other things like reduced inputs and reduced labor and other things happening on the field, sometimes you have different results, right, between yield and profitability. But in terms of the ecosystem services, the long-term dream is to be able to take what we have in the SHAPE tool and that model and then tie it to outcomes. And so add that other layer of like water quality, but it would have to be in places where we have the data, and it would likely be done on a regional basis. But yeah, that's the dream. So
that's the dream. There you go. That's a great way to end the panel. Wayne, I'm going to kick it back to you, okay?
Great. Thank you so much. And thank you for all the panelists. That is a perfect setup for the very next session. So thank you all for that. Mara, Jason, Cam, Kristen, Christine, thank you all so much for a really, really engaging session.